Hello, everyone. Welcome to class number 1. This is Mrs. Nesser. Hopefully you watched my video so you can actually see my face. In these recordings, you actually won't see my face. You will hear my voice and you will actually see my handwriting. So this is the quickest way, and they download great, and they should be fast and pretty easy to watch. But anyways, this is how I will be doing the recordings. So this is class number 1. And usually in class number 1, I do discuss the syllabus. So here it is. It is online for you to print if you would like it. But my email is on here and also cell phone. But I will check my email daily. Okay, so feel free to email me as well. As far as office hours, I will do that via Zoom if needed. This class is called Elementary Functions. It is an overview of all functions of mathematics. So we will start off with linear, and we will actually move the whole way through trig. Okay, so that's basically where we end. But we will look at polynomial functions, rational functions, exponential functions, logarithmic functions, almost every function of mathematics. But that's the idea. The book is called Pre-Calculus. It is a blue book. Don't let the name scare you. I think it's more so an elementary functions course, which is actually a great name for the course. Okay, so as far as attendance, you are expected to watch the videos and turn into quizzes in a timely manner. As far as the tests, obviously you are responsible for those. There will be no leeway as far as lateness for any of that. You can read all of this. As far as the grades, you must complete the exams on the specified dates. All exams will be timed. Complete work shown for full credit. All exams must be taken by all students. They will be posted at 4 p.m. They must be emailed by me at 6:30. So in my mind, I figure you have 2 hours to complete the exam and 30 minutes to actually upload it. Homework is assigned regularly. Even though it will not be checked, it is a great way to learn the material. Quizzes are given online, take-home format. They are due weekly. The due dates are all on the syllabus. A final cumulative exam is at the end. It will be given in the same format as all of the other ones, and the grade will be calculated by total points, and you can see your grade in Schoology. Okay, so I will keep the grades updated pretty precisely. Okay. As far as an online overview, here's kind of an overview I made, just so you can kind of read through and get an idea of what every class will look like. It's important to get into routine, especially with an online class. So try to get yourself into a routine. That way you'll fare better off with the work and with getting everything done by the due dates. Okay. As far as the course calendar, here it is. So today, the first class, Monday, I will be covering sections 1.1 and 1.2. And I do have bad news. Those are word problems, blah. But I like to get them out on day 1. That way you can practice them a little bit longer before the exam. So this will be the first recording. There will be 2 videos, I believe, okay, for this one. I'll separate it. I'll do section 1.1 and then I'll do section 1.1 together, and then I'll throw the word problems in on the second video. Okay, but other than that, that's what we want to accomplish today. You can see here's the homework that's listed. Those are problems that are in your textbook. So if you'd like to try those, like I said, they get a little bit challenging here towards the end, but I like to throw a couple in there anyways to challenge you. The more you know, the easier it's going to be. So that's kind of the idea. But you can work on those homework, but like I said, those homeworks are not graded. You will also see me post today a quiz number 1, which will correspond with class number 1. So everything on quiz number 1 will be from these 2 videos. Notice that quiz number 1 is not due until next Monday. Okay, so you have a whole another week to do this quiz. I do have to receive it by 6:30. Everything is due by 6:30. Okay, so I kept that consistent for you. Even your exams will be due by 6:30. Okay, so technically that was the end of class. So I have everything due at 6:30. So notice quiz 1 isn't due until next week. So you do have 1 week to complete that quiz. be sure you're working on that quiz and completing it. Like I said, that will help you for when the exams actually come. Okay, without further ado, let's jump into Chapter 1, Section 1. Okay, so Chapter 1, Section 1 is linear equations. And we'll start off very basic. Linear equations, you may know them. The good thing is a line. These are a lot of equations that are typically done in Algebra 1. So we're going to kind of take a step back and we're going to start at linear and we're going to go up through. Okay, so a couple things about linear equations. First off, the formal definition of a linear equation is an algebraic expression that can be written in the form ax plus b equals 0. Okay, where a cannot equal 0, okay, and a and b are constants and x is the variable. So those are just numbers, and x is the variable. And notice a couple things. I like to say in linear, you are dealing with a line, and you typically usually have x to the first power. You will not see an x squared. You will not see x to the third. You will see an x to the first power. That will be the highest power you will see in a linear equation. Okay, and as we move up through, we will be using that as we talk about all the other equations. For example, x squared would be quadratic, and we'll talk about the names of those. And we'll also actually eventually look at the graphs of all of those. Okay, so, but that's kind of the idea. X to the first power is a key that it is going to be linear. Okay, so the main thing we are going to look at is solving, obviously, a linear equation. When you solve a linear equation, there's three things that could happen. You could get a solution, and I mind you, one solution. Okay, so that does correspond with the power. Since x is to the first power, you do only have one solution. The second thing that could happen is that you could have no solutions. So keep in mind of that. When you have no solutions, your variable will drop out. Okay, so you will end up with a false statement, and if you end up with, the board needs a second, if you end up with a false statement, that does indicate no solution. There is no answer to that problem. There is no value of x that will make that problem true. And then the third thing that could happen would mean that there are infinite solutions. That does mean you have an identity, and the left-hand side of the equation will always equal the right-hand side equation, no matter what value you stick in for x. So this will end up in a true statement at the end, and you will see that that would be something that would end up to be true. Let me give you an example of those. A solution would look something like x equals 3. False statement may come out to be like 0 equals 4, which we all know is not true. And then the infinite solutions, you may end up with something to the effect of 8 equals 8. Okay, so that would be true. Okay, so as far as that, I like to jump into examples. I do like to teach by examples. Before I jump into the examples, though, I want to just outline some steps to solve here that we're going to be looking at. So steps to solve, these are pretty much the same across the board. I just like to highlight them out and put them out here so you can see them. This is the way I do it. There may be other ways to do it, but this is the way I tend to teach. So the first thing is to clear the fractions, and I do use the LCD, or the least common denominator method, for that. But we do clear the fractions if there are fractions. The second thing would be to distribute. Okay, and we'll talk about that, what that is, in a second. The third thing would be to combine like terms, and this is where I think it gets a little tricky. You have to combine like terms on the same side. Okay, so you have to look at the left side, combine anything that you can, and look at the right side and combine anything that you can. Okay, so you can't mix and match the sides. That comes on the fourth step. Now you need to collect your variables to one side. And no, it doesn't matter which side, but I'm old school, so I like to put mine on the left. But then it gets a little tricky when you're moving variables across the equal side. So that part, as far as collecting variables to one side, and then usually you collect constants to the other side. But after that, I like to just call it working backwards. And when you work backwards, you are doing opposite operations at this point, and you do have to work backwards, undoing addition or subtraction first, and then multiplication and division. Okay. And just for the sake of time, there's plenty of problems for you to practice in your textbook if you need extra practice. But I'd like to do a few here so you could see them. Okay, so example 1. And we'll start off very easy. Solve. Okay, and a lot of you probably remember this from school. You would subtract 3 from both sides. 5x equals 20. Divide by 5, and you get x equals 4. Okay, one solution, pretty basic. Nothing too crazy about that problem. And of course, I could get harder and harder and harder. So second example. Let's go ahead and solve this one. And I am going through the steps. Okay, so I'm looking at the C. Is there fractions here? No, there isn't. So the next step would be to combine like terms. Well, you can't combine a 5x and a negative 9. They are not like terms. You need another x to combine. Okay, so we can't combine. On the right, I have a 3x and a 7. Those aren't like terms either. Okay, one's a number, one's a variable. So I can't combine those either. So the next step would be to collect my variables to one side. So I would really like to take this 3x and put him on the other side. And I've learned it as a couple different ways. You can actually visually think of yourself as actually picking up this 3x and moving him to the other side. Okay, so he's no longer there. You could think of it as subtracting 3x from both sides, which a lot of teachers do teach that. So you are getting the 3x away from here, and you're putting it over there. So it goes away here, but it has to go somewhere. Okay, so it does go on the other side. Whatever you do to one side, you have to do to the other. 5x minus 3x is 2x. And then you just recopy, keep your work neat, and then you always end up back at example 1. So add 9 to both sides from here. 2x equals 16. Divide by 2. You get x equals 8. Okay, so a little harder, still not really majorly challenging, and again, you could practice if needed. So let's go ahead and do example 3 here. I went for the gold on example 3. No fractions yet, though. They're coming. Don't worry. Fractions are our friends, not our foes. Okay, so everyone's always scared of fractions. Don't be scared of fractions. Okay, so on example 3, I look and see there's no fractions. Distributive property. Is there a distributive property? Well, yes, there is. A distributive property is a spot where there is a number out in front of a parenthesis. That number has to get multiplied by every single thing in that parenthesis, hence the reason there's parentheses around it. And furthermore, I actually put 2 harder distributive properties on here. And I'm going to give you a minute to think of why. Why would I say that these are harder? Hopefully someone's raising their hand out there. I can't see you, but if you are raising your hand, you might be saying you have to distribute the negative. Absolutely. This is a negative 3. Okay, and we have to distribute first because technically that's multiplication. And order of operations says we cannot do 4 minus 3. So don't do that. You must distribute first. So negative 3 has to get multiplied times everything in those parentheses. And yes, guys, negative 3 times 2 is negative 6. Be very careful. On the other side, you have a 5x, and then we have to distribute a negative 7. And yes, I did it again. So negative 28, and negative times negative is what? I teach Algebra 1 at the high school, and this is the most missed thing, just because students work so fast. So negative times negative is positive. Okay, at this point, now I'm looking at the left-hand side and I'm looking at the right-hand side. So here's my equal sign in the middle. I'm looking at the left and I'm separately looking at the right. Is there anything I can combine? Well, yes, there is. There's a 4 and a negative 6 right here that I can combine. So I have a negative 3x, and then that makes a negative 2, okay, when I combine those. I do like to keep my x terms first. Technically, they should be first in standard form. Other side, I have a 5x, and I do have a 7x. So 5x plus 7x is a 12x. And I'm just going to carry down the negative 28. Okay? All right, now I've combined my terms. Now it's time to collect variables to one side. Now I'm going to go against everything I think here, but I'm going to take this negative 3x, and I'm going to actually put him over here on the other side. Now make sure you're taking him to the other side of the equal sign. This equal sign's like, I saw a YouTube video once, it's like a little bridge. Okay, you got to go across it. Now you can't put the 3x on two sides here. It has to be one on the left side, one on the right side. So it's going to go away here, and over here, it's going to make 15. Okay, now does anybody know why I actually put it on the right side? It's a strategy. If I move it over on the right, I don't have any negatives to deal with. Okay, so it becomes a positive 15x. Now, if you like, you can switch that around if it bothers you, but technically you would add 28 to both sides. Once you add 28 to both sides, you get 15x equals 26, because that is 28 minus 2, by the way. And then divide both sides by 15. And, does 26 divide by 15? No. Okay, does it reduce? Okay, so we should check to see if it reduces. No. So therefore, you can just leave your answer like that. That is fine with me. It should be reduced. We like fractions to be reduced in lowest form. Okay, so I will check to see if you're reducing that and making sure that that is in lowest form. Okay, lastly, for equations, is the ones with fractions. So let's move on to example 4. Okay. A lot of kids sometimes panic when they see fractions. Don't panic. Please don't panic. There is a great method for getting rid of fractions, and you guys are really good at it. And it goes back to elementary school, when a teacher told you to find the least common denominator. And you guys are very good at that. I could give you a slew of numbers and ask you what the least common denominator would be, and I bet you all of you could pick it out. So 15, 5, 6, and 10. What is the least common denominator for that problem? Give you a few minutes to think about it. 30. I could turn all of those into a 30 with simple multiplication. Okay, so how do I turn a 15 into 30? I times it by 2. Now you have to keep in mind, you have to times the top as well. How do I turn a 5 into a 30? Times it by 6. How do I times a 6 into a 30? I times it by 5. Well, time out. There's two things up top. So that becomes a distributive property. And 10, how do I times that? I times that by 3 to make a 30. Okay, so once that's done, then you can rewrite your equation. And I go ahead and distribute the top while I'm at it. So 2x plus 20 over 30. Then you have 6 over 30. Then you have 5x plus 5 over 30. Then you have, whoa, not 1. Sorry, it's been a long summer. 1 times 3 is 3 over 30. Okay, now why did I just do this? Because here's the beauty of it. I have a nice eraser here. You can literally get rid of all of the 30s. Guys, it's magic. Okay, why are you allowed to do that mathematically? Because you would multiply both sides by 30 and they would all disappear. Okay, that's the way I like to teach it. So get the LCD and cross it off. Okay, so once you get the LCD, you do cross it off, and then you just continue on your way in solving. I need to look at the left, look at the right. There's no distributive property because I've already done it. But I can combine my 20 minus 6, that makes 14. On the other side, 5 minus 3 makes 2. Cut my variables to one side. I'm going to go ahead and subtract 2x. Let's move the 2x. Keep in mind the equal signs in the middle there. 14, then I get a 3x plus 2. Work backwards. You add or subtract first before you multiply or divide. You end up with 12 equals 3x. Divide both sides by 3, and voila, you end up with x equals 4. Okay? So that was, of course, the hardest problem there is. But it does involve the fractions. And it's not necessarily harder if you know that LCD step. Okay, so if you need to rewatch that, please do. But that's a great technique to get rid of linear equation or fractions in a linear equation. Okay, so with that said, I should do some word problems, but I'm going to go ahead and make those for a separate video. So that will be the second video today. So before I go into word problems, I do want to do chapter 1, section 2, because it's very closely related to linear equations. In fact, it is now linear inequalities. Okay? And we changed the game a little bit. So linear inequalities. So let's talk about what inequality means. So that does mean not equal. So you are going to see less than's, greater than's, less than or equal to or greater than or equal to. And that is now going to pop out. Okay? It is the exact same thing as a linear equation. However, you now do not have an equal sign in there. You have one of those. Okay? So the key is they are solved the same way. Okay, so as far as clearing fractions, distributing property, combined like terms, they are solved exactly the same way as a linear equation. Now, when you get your solution, solutions can be expressed in 3 different ways. And we are going to do all 3. Okay, so the first way is going to be in inequality notation. And this is typically just the answer that you get. Okay, so when you're done solving, that's typically just the answer that you would get there. The second type that you can express this, you can express it graphically. Okay, and that would be on a number line. And the third and final way to express this would be in interval notation. And interval notation may be something new. Not sure if you've seen it before, but interval notation is the notation with brackets and parentheses. Okay, so just to give you kind of a heads up, there are 3 different ways we are going to express this answer. Okay, so I probably need to do a little bit on interval notation first, just so you can kind of see what that is if you've never seen it before. So let's take a look at interval notation. Okay, and interval notation is a lot easier to do on a graph, in my opinion. It's a lot easier to see it. So when we actually do our examples, I'll kind of go over that with you. But first off, if you come out with x is greater than 1, okay, what numbers can make sense for x? If I said greater than 1, so you're probably all sitting out there saying 2, 3, 4. What about 1.5? Yes, 1.5 will work. What about 1? Will 1 work? Hopefully you guys are all out there shaking your head no. 1 will not work. I need anything greater than 1, but I have to start at 1. Okay, but it cannot equal 1. And then any number bigger than 1 will work. That's called infinity. So a couple things. If it is just less than or greater than, you're going to have parentheses. Okay? However, if it's less than, greater than, or equal to, you are going to have a bracket. The last thing is infinity. Well, that's a bad infinity sign. The last thing is infinity. If you see infinity, it is going to have parentheses as well. I had a math professor once tell me, infinity, you cannot touch it. Okay, so therefore it does get a parenthesis. Well, I think he said, think of all the sand in the world. Think of every grain of sand if you counted it individually, and you're still not even close to infinity, which that's mind-blowing. But infinity can get very large. Okay, another example here, let's just do a few. What if I did x is less than or equal to 2? Okay, so as far as 2 works now because I have the equal sign. So 2, you do start. That would be the upper limit. Now, how far left does this go? It does go towards something called negative infinity. Okay, so a couple things about interval notation. You do have to work like from left to right. Okay, so this is kind of like your smallest number, and this is going to be your largest number. Okay, so they are, because that's how you would read on a number line from left to right. So you would read from smallest to largest. So you have to have the smallest number first. And then as far as a combined inequality, which we will look at a combined one here. Right now we're just going to look at the and ones. But if you look at a combined inequality, your answer, for example, let's do -3. Okay. And it's not difficult. It just means in between. Your answer has to be in between -3 and 2. That's it. Okay? I actually think it's kind of easier, to be honest. It starts at -3 and it goes the whole way to 2. So that's easy. Starts at -3 and goes to 2. Now the question is, can it equal it? And it cannot equal -3, so that would get the parenthesis. And as far as the 2, it can equal, so that would actually get the bracket since you can equal that. Okay? All right, so with that said, let's go ahead and look at solving linear inequalities. Okay, so example 1. So, and we'll look at all the different ways to represent the solution as well. Okay, so first example I have for you is 2. All right, and again, you do the same thing. So you would distribute first. So 2 times 2 is 4x plus 6 minus 10 is 6x minus 12. Then you look at the left and the right, and on the left-hand side, I see something to combine. 6 minus 10 is -4. Now I have x's on both sides. Now this is where I agree with my 8th grade Algebra 1 teacher. She made us get the x's on the left. And I actually think that's kind of important. I teach Algebra 1, like I already mentioned, and my success is if I have the kids get the x's on the left, they're less likely to miss all of these questions. It's doable to do them on the right. You just have to be very careful with your graph when you get to the bottom. Okay, so if I move my x's to the left here, so I'm going to take these 6x's, I'm going to subtract 6x from both sides. Notice I'm not doing anything different with my sign yet. Okay, keep on working backwards. I add 4 to both sides. I get -2x is less than -8. And at this step right here, I divide both sides by -2. And are you guys going crazy out there yet? Because everyone remembers this. I rarely see someone who does not remember this. Ready? Divide both sides by negative. What do you have to do to the sign? Yes, you are right. You have to flip it. Okay? So please pay close attention to that. You do have to flip that sign. Okay, so this popped out. This is inequality notation. Okay? Now, I'm not sure about the graph. If your teachers how they taught the graph notation of this, I've always learned it as open circle, closed circle. Don't know if you remember that or not. But I always tell my kids, show me where 0 is and approximately where the answer would be. So it's to the 4s to the right of 0. Now, since there's just a greater than sign without the equal to under it, technically you would get an open circle at 4, and you would draw your arrow or shade. I usually shade like that. Sorry, that's how I do it. On top of all the solutions that make sense. So 5 works, 6 works, 7 works, of course. All those numbers up there work. Okay, so just again, this is the graph representation of it. And just a little side note here, open circle, and if it does have the equal sign, it would be a closed circle. Okay. Some teachers have actually been putting the parentheses right on the graph, so which is actually very helpful because when you go to interval notation, okay, interval notation is kind of like where your graph starts and where your graph ends. And remember, we read from left to right because that's how we read. So if I'm walking along this graph, I start at 4. However, I cannot equal 4, and my graph goes the whole way to infinity. And again, likewise, you cannot equal infinity. So that would be the interval notation. So there's 3 representations of the answers here, and you will have to do all 3. Okay, so keep that in mind. I will have you do all 3. Okay, example 2. Okay, no distributive property in this one, so we do just have to combine like terms on the right. 10 minus 5 is 5. Like terms, I'm going to collect my terms to the left. Negative 2x minus 3 is greater than or equal to 5. And from here, add 3 to both sides. I end up with negative 2x is greater than or equal to 8. And when I get down to here, oh no, divide both sides by negative. You have to flip that sign. And caution, don't forget to do that. Okay, so again, there is your inequality notation. As far as the graph is concerned, you have 0 and negative 4 would be to the left. Now this one has a line under it, so that would be a closed circle at negative 4, and anything less than negative 4 or to the left is the solution. So that would be how I would represent it graphically. Now interval notation, sometimes this confuses people, but where does this graph start? I don't know, way left. So technically it starts at negative infinity, because remember, we read from left to right. Okay, so where's my graph stop at? It stops at negative 4. It does not go past that, and that would be your bracket because you can equal negative 4. Okay, so that would be the closed circle there. So that's another example. I just figured I'd do one of each way for that so that you could see it. Okay, and the last 2 examples, 3 and 4, are going to be your combined or your compound inequalities. And these are actually very useful. If you think of a grade, if your grade's in between an 80 or an 89, what are you getting? If your grade is in between, you know, an 85 or an 89, what are you getting? If it's in between an 83. So there's so many things in life that we look at that's in between. Okay? So with that said, we'll do example 3 and 4, and I'm going to go ahead and do them together here. So example 3 is this, and I want you to look at something here. In example 4, I have a fraction for you. Oops, no, I don't have a fraction for you. I lied. No, kind of. Okay. So as far as both of those examples, all right, now I want you to look at something. The equation for a compound inequality is inside the 2 sides. Okay, so my highlighter's slow at coming out here. I swear I have a highlighter on this board. But the equation is actually in the center of the two inequality signs. Maybe I'll just box it like this. Okay, so if you take a look, you can see the equation. Oh, well, now look at that. I have highlighting and a box. Nice. Okay, so if you look at the center, you will see the highlighting and you will see the equation. Okay, it's right there. It's in the middle. Okay, so focus your eyes on the center. Now you still work backwards. So let me actually look at example 4 first because I feel like that one's set up right. So 6x minus 1. If I saw that on an equation, what would I do to both sides? Oh, I would add 1. Guess what? You have another answer. You have a minimum, you have a maximum. You have to add 1 to the center and to both sides. Okay, I like to just solve this together. It's a little bit quicker and I can recognize it easier. Now I have 6 times x, so what do I do to both sides? I divide by 6 and you end up with negative 1/3 is less than or equal to x is less than 2/3. Okay, and as far as the notations, that would be inequality notation. Graphical would look, you'd have 0 in the center, negative 1/3 and 2/3, and it would be in between with a solid circle at negative 1/3, and interval notation would be negative 1/3 to 2/3 with a bracket at negative, but a parenthesis at 2/3. Okay. Likewise over here, this equation is a little bit backwards, so you do have to subtract 7 first here, because that's a positive 7. It's a negative 2x, but it's a positive 7 here. So subtracting 7 gives me negative 10, and I'm left with a negative 2x, and I'm left with a 0. Okay, no problem. 0 is a number. Let's just keep going. Divide everything by negative 2. Uh-oh, what do you think? I'm dividing by a negative. Do I have to switch the sign again? Absolutely. Do you switch all of them? Absolutely. Okay? 0 divided by anything is 0. You do have to flip the signs. And there is a reason why you do have to flip the signs. Fun fact, the signs will always point towards the smaller number. So technically this inequality is written backwards because it is, oh, remind me tomorrow, because the 0 is smaller than the 5. Okay, so keep that in mind. This is backwards. We should be able to write it like that. Okay, and you can switch it around. These are the same thing. And this is where inequalities can get a little confusing. Okay, so practice makes perfect. So make sure you do practice those. As far as the graph, you have 0, you have 5, close circle at 0, open at 5. Could be a little piece in the middle. And as far as interval notation, it starts at 0 and it goes to 5. Okay, so it's important to recognize that these are the same. That way you don't miss the graph, okay, or the interval notation on that. Okay, so, but as far as that, you do have to switch it, and the sign should always point towards the smaller number. So if you take a look over here at this example, the example 4, the signs do point towards negative 1/3, which is smaller. Okay, so as far as inequalities, that's what I have for you for inequalities. But they're very similar to equations. So that's why I like to teach them together, because it is a consistent topic. Okay, that's enough for one video. That was a nice 40-minute video. I don't think the word problems are going to be as long, but they're word problems. So tune in for the next one, and that will be the word problems. I do have a blank copy of this on Schoology so that you could pull it off. Okay, see you guys next time. Thanks.